Hello everyone, welcome to your favorite channel, that is BYJU'S Exam Prep. I am Deepak Mishra and here we are discussing IISC PYQ series 2002, 8 and 16. So now I will discuss theory of concept. Fine. So I will try to discuss all the question of TOC which asked in year 2, 8 and 16. Fine. There are approx 35 questions. So I will try to finish in 40 minutes. Fine. Okay. So I'm starting now. Okay, so this is my Telegram link. You can join this link for daily dose to improve your concept, for daily important questions. And if you have any doubt regarding the class or anything, you can ask me here. Okay. And okay, so yeah. So UPSC ESE 2023 mains exams results out. Fine, my dear friend. You can share your result and you can get free mock test to our interview, free mock interview with our expert panel, my dear friend. That is very helpful. Fine, very helpful for you, my dear friend. Fine, this is free only. So those who have cleared UPSC ESE 2023, they can share their result and they can get free mock interview with our expert. So yeah, so this is the question, my dear friend. See this question, try this question. Fine, I am waiting for the answer. Please try to reply. Okay, I am reading this question. Read carefully. This question asking 2 marks. Okay, so see clearly the finite state machine described by the following state diagram with A as a starting state where an arc label X by Y and X stand for 1-bit input and Y stand for 2-bit output. It is nothing but, it is Melee machine they have given, and they have given some option here. See here, output the sum of the present, outputs the sum of the present and the previous bits of the input. Output 0, 1 whenever the input sequence contain 1, 1. Output 0, 0 whenever the input sequence contain 1, 0. And D is none of the above. None of the above, my dear friend. Fine. Okay. So you can see here, it is a Melee machine. See clearly here. Let me see the option here. What they are telling, output is 0, 1. Output is 0, 1 whenever the input sequence contain 1, 1. Whenever output is 0, 1, see here, whenever the input sequence contain 1, 1. 1, 1, my dear friend. 1, 1. Fine. See clearly. So see clearly. See here, if it is 1, it is 0, 1 also. And it is what? 1, 0 also. So this option is what? False. This option is what? False. Fine. Because they are telling actually output is 0, 1. Fine. Whenever the input sequence is 1, 1. Input sequence is 1, 1. If you see clearly, for 1, what is the output? 0, 1. It is true only, but here it is false. For input 1, the output is what? 1, 0. So that is false, my dear friend. Okay. Now in the C option, what they are telling, output is 0, 0 whenever the input sequence contain 1, 0. Input sequence contain what? 1, 0. See clearly? 1, 0, my dear friend. The input sequence what? Contain 1, 0. So see clearly, if it is 1, if it is 1, my dear friend, 0, 1, and if it is 0, it is what? 0, 1. So it is also what? False. Output is 0, 0. The input sequence is what? 1, 0. The input sequence is 1, 0. This is also false. Now, if you see this option, output the sum of the present and the previous bits of the input. See clearly here, output the sum of the present and the previous bits of the input. So for this one, what you do, my dear friend, you can take some random input, fine. You can take some random input, fine, and try to find out the output, fine, without using the machine, fine. And after using the machine, if you'll get the same output, it means this is correct. Sir, I am data science student. Can I prepare for GATE exam 2024 in 5 months? Yes, definitely you can. Already course has been started, Subham. Fine. So yeah, Satya sir is taking Python classes. After that, like machine learning will start. Definitely you are able to qualify with good marks also. Fine. Definitely you are able to qualify with good marks. Okay. So see clearly. Let me take some value here. Let me take some value. Any random value. 1 0 1 1 0. Fine. 1 0 1 1 0. Fine. Don't take all 0 or all ones. Don't take it all 0 or all ones. Fine. Take combination of 1 0 1 1 0. See clearly. So without machine, what is the output? See, let's suppose, see here, by default it is 0. So what is the output? What is the output, my dear friend? It is nothing but 0, 1. 0, 1. See, see here, the sum of the present and the previous bit. So it is nothing but 0, 1. 0, 1. Fine. Now what is the output for this one, my dear friend? So this is the present bit. This is the present bit, my dear friend. This is the what? Present bit. fine, and this is the previous bit. This is the previous bit. Are you getting my point? Are you getting previous bit? So what is the output? Output is what? 1 0. Output is what? 1 0. Now see clearly. Now see this one. Without seeing this one, I am writing the output. See here. See, what is the previous one? Previous bit is 0. And what is the present bit? 1. It is nothing but, my dear friend, 0 1. 0 1. What about this one? It is nothing but, see here, the present bit is 1 and the previous bit is 1. So it is nothing but 1 0. What about this one? See, the present bit is what? Present bit is what? 0. And the previous bit is what? 1. It is nothing but 1 0. 1 0. So that is the output, my dear friend. That is the output. See clearly here whether it is satisfying here or not. See clearly. See, if A, see if 1, it is nothing but 0 1. 0 1. Fine. 0 1. 0 1. If A, it is nothing but 0 1. Okay, fine. It is 0. So it is nothing but, see, sorry, it is 0 1. No? I think I have written something wrong. Let me correct it if I have written something wrong here. It is nothing but 0 1. 0 1. Fine. Now it is 0. So it will become what? 0, present and previous. Okay, fine. I have done something wrong here. Let me correct it. Let me correct it. Sorry for the mistake. Yeah. Let me do once again. Okay. See clearly. So it is nothing but, see, what is 1? By default it is 0. It is nothing but what, my dear friend? It is nothing but 0 1. Without seeing the input. See here, present and the sum of the present and the previous output. See, what about 0? See, it is nothing but, what about 0, my dear friend? It is nothing but 0 and 1. 0 and 1. What about this one? What about 1, my dear friend? 1 plus 0. It is nothing but 1 0. What about this one? This one, my dear friend? 1. See, 1 plus 1. It is nothing but 1 0. 1 0. That is fine. What about this one? See, what about this one? It is 0. So 0 plus 1. It is nothing but 0 1. Fine. That's it. That's it, my dear friend. Fine. Now, if you see clearly, this is 0 1 0 1 1 0 1 0 0 1. Now, if you see clearly, now you can see the machine, my dear friend. You can see the machine. See here. For 1, what is the output? For 1. 1 output is what? 0 1. Output is 0 1. For 0, what is the output? 0 1. Fine. For 1, what is the output? For 1, what is the output? 1 0. 1 0. 1 0. Fine. For 1 second, 1, what is the output? 1 0. No problem. For 0, what is the output? 0. 0 1. Fine. So I think A is the correct one. A is the correct one. This is very easy question. Fine. This is very easy question. Such type of question, what you need to do? Fine. See clearly here in the B option, they are telling output 0 1 whenever the input sequence contain 1 1. Means, see here, output is 0 1 whenever the input sequence is what? 1 1. No, it is not right. See, for 1, what we have? For 1, we have 0 1. And what is the next input? 1. So we have what? 1 0. So that is wrong. Like that for C also. Fine. Now if you try for A, you can take any input. The input should be not contain all 0 and all 1s. Fine. First, what you do? See, before this one, no bit is there. So you need to take 0 as a default. Fine. So it is nothing but 0 1. Fine. Now what we have? So it is nothing but, see, present plus previous. So 0 1. Present plus previous. So 1 0. Present plus previous. So 1 plus 1. That is 1 0. Present plus previous. That is 0 1. So without machine, this is the output. Now you can match with the help of machine only. Fine. So if it is matching, you can say A is the right option. Fine. So here A is the right option. Okay. Now if you see this question, the smallest finite automata which accept the language X, length of X is divisible by 3. See, this is nothing but modem machine. Fine, everyone know. The answer will be what? N state. Fine, 3 state. If it is mod 3, this is nothing but divisible by 3. So if it is divisible by 3, it will contain what? 3 state. Divisible by 5, it will contain what? 5 state. Fine. Are you getting my point? See clearly. So if you want, you can draw the automata also, like we have what state. If you want Q0, like what we have Q1. Let me draw also Q2. For input 1, I am just trying, and this is nothing but 1. And this will be the final state. This is initial and final both. Fine. So just you remember this one, like if divisible by 3, like it will contain 3 state. Fine. So this is nothing but remainder 0 and 1 and 2. Fine. If you want, you can try input for 0 and 1 also. Fine. It will take time. You just remember it. Modern. Fine. So 3 will be the answer. Now see this question. Consider the following regular expression describes the language over 0 1 consisting of a string that contain exactly 2 ones. Now they're asking about exactly 2 ones, my dear friend. Exactly 2 ones. So which of the following option is correct? Exactly 2 ones. Such type of question, fine. It will like sometime it will like difficult to find out which of the following is correct. So you need to take some input string. fine, input string, and if it is satisfy, you will say the answer, like you can find the correct answer. So if you see correctly here, what is telling, see here, any number of 0 or 1, fine, 1 1, and what, any number of 0 or 1. So they are telling at least 2 1. See, at least 2 1, my dear friend, here at least 2 1 is here, fine. So it will not be the option because they are asking about exactly 2 1s, fine. See, dekho, it is nothing but, see, x 1 1 x, fine. So see, before 1 1, any number of, see, 0 plus 1 clean closure. After 1 1, what we have, 0 plus 1 clean closure, fine. Now they are telling here exactly 2 1s, my dear friend, exactly 2 1s. Here, see here, exactly 2 1s. Now if you see here also, what is happening here, it is x, it is 1 x 1, fine, x, and it is nothing but, my dear friend, 1 and x, 1 and x. So my dear friend, this D is also not be the answer, fine. D is also not be the answer. A is also not be the answer, fine. Now if you see clearly, maybe you have doubt B and C, my dear friend, B and C. But see here, exactly 2 1s, it need not be conjugative, fine. वो conjugative जरूरी नहीं कि वो conjugative हो. If you take, see here, 0 1 0 1, 0 1 0 1. Can we make 0 1 0 1 with the help of 0 star 1 1 0 star? Can we make 0, fine, then 1? So no, definitely. So B will be not the answer, because here also we have exactly 2 1s. So it will satisfy in option number C, my dear friend. So C for Chennai is the right answer for this one. See clearly, we have exactly 2 1s, fine. 0 clean closure 1, 0 clean closure 1, 0 clean closure. So C will be the right option for this one, fine. Okay, exactly 2 1s, but it need not to be conjugative. देखो यहाँ तो conjugative 2 1s है ना, but see here it need not to be conjugative. See 0 1 0 1 हमारा B के अंदर इस accept नहीं करेगा. It will not accept in B, but it will accept in what, C. C के अंदर क्या करेगा, accept करेगा. So such type of question, what you need to do, you need to take a string, fine, you need to take a string, and whether if you have doubt, and if you have any doubt, you can just, whether the string is what, like satisfy with this condition or not. It will not satisfy, you cannot make this, fine. With the help of this one, you cannot make this. With the help of this regular expression, you cannot make this. Already I told you, Subham, yes, 5 months is sufficient time, fine. If you are like, if you are honest to yourself, and if you are really preparing for GATE DA, fine, data analysis, fine, definitely you are able to crack GATE with good marks, definitely, fine. Is that clear? Is that clear? Fine. Okay. So in this one, I think you have already seen exactly 2 1, but for any number of 0 or 1, fine. So it will not be the answer. So answer will be what? C for this one. C for Chennai is the right answer for this one. Okay. So I'm moving now. Now this is, see, this is the next question. Please try. See, let N be the NFA with N state and M be the minimum DFA with M state, recognizing the same language. Which of the following is necessary true? So you know, like DFA is fine. Thank you. So in DFA, number of state will be subset of the number of state in NFA. So what will be the answer? Answer will be what? A for Ahmedabad, M less than equal to 2 to the power n. Fine. This is very easy question. Fine. I'm moving forward to next question. Okay. Now see this question. If the final state and non-final state in the DFA below are interchanged, then which of the following language over the alphabet AB will be accepted by the new DFA? So it is a DFA, fine. So it is a DFA, my dear friend. So in DFA, see here, whenever you change final state to non-final state, fine, the language will be what? Complemented. The language will be what? Complemented only. So if you see this grammar, it is nothing but, see, ending with AB. See the grammar here. See, it will accept AB. It will accept AB here, AB, fine. It will accept what, see here, if you want, see, AB, AB. It will ending with AB, my dear friend, always ending with AB. Always ending with AB, AB, fine. Or it can start with B also, so like B, AB, see, B, AB, fine. Or you can say B, A, B, A, B, or B, A, B, B, A, B, fine. It will always end with A, my dear friend. Sorry, always end with AB only, fine. So it is always end with AB. If you see clearly, always end with AB. So, my dear friend, what you need to do, they are telling actually in this question, just interchange final to non-final and non-final to non-final, non-final and non-final to final. So, what will be the accepted by the new DFA? It is nothing but, see, what it is ending with AB. So, definitely the complement of this language, the complement of this DFA, set of all string that do not end with AB. So, answer will be what? A. A for Ahmedabad is the right answer for this one. But in the case of NFA, it will not be. NFA के लिए आपको कॉम्प्लीमेंट अगर आप करेंगे तो ऐसा नहीं होगा कि जो लैंग्वेज होगी जस्ट उसके कॉम्प्लीमेंट हो जाएगी, ऐसा नहीं है. Fine, NFA में नहीं होगा. If DFA, you can blindly what you do, just convert. If you find complement, just make non-final final and final non-final. Fine, and definitely, my dear friend, you will get the right answer. But in case of NFA, please don't do this. Fine, okay. Now, see clearly this one. Which of the following languages are non-regular? They are asking about non-regular. Fine, they have given L1, L2, L3, and they have given, see here, L2 and L3, L3, L1 and L2 and L2 only. Fine, they have given some option clearly. So see clearly, see, see here, L1 0 to the power m, 1 to the power m, where m and n is what? Ranging from 0 to 10,000. It is finite, and something is finite, it will be what? It will be regular. The first one is what? Regular. Because it is finite only, no? So it is regular, my dear friend. It is regular. If you see clearly this one also, W belongs to 0, 1 clean closure. W contains an even number of zeros and even number of ones. You can write the regular expression for this one also. Even number of 0 and even number of ones. Find even number of 0 and even number of ones, my dear friend. So definitely it is also regular. It is what? Regular. This is also regular because you can write the DFA of this one. Fine. Now if you see this one, W such that W reads the same forward and backward, my dear friend. So it is nothing but it is CFL. Fine. So you cannot do with the help of like finite automata. Fine, because it needs stack. Like if let's suppose if they will give any palindrome, it will be not accepted by the finite automata. Fine. So definitely it will be CFL. It will be not be a regular. So I think we have option L1 and L3. So L1 and L3. They are asking not non-regular. So non-regular will be L2 only. So D will be the right answer. Non-regular they are asking. So non-regular will be L2. Fine. 6 is L2, my dear friend. L2 is the right answer for this one. Fine. See, see, this is what? Finite. If anything finite, it will accepted by finite automata. That is regular. Fine. This one also you can draw the DFA of it. Fine. You can draw the DFA of it. It will take how many state? I think 2 into 2, 4 state it will take. Fine. So you can design the DFA of this. So it is also regular. But yeah, this one you cannot see. This one you cannot write regular expression for this one. Fine. So it is nothing but it is CFL. Fine. Okay. Now see this one. See this one, my dear friend. Consider the following two finite automata, M1 except L1 and M2 except L2. Which one of the following is true? Which one of the following is true? They are asking about. Fine. Which one of the following is true? They are asking about. So, sir, I have built a frame, submitted the payment, but I have uploaded fingerprint in place of signature. Now I'm worried. What should I do? Don't worry. If I think added option will be there. Like they will once they will give you time to correct it. Fine. There, Abhishek, no need to worry about it. Fine. Focus on your preparation. Fine. Your form will not get rejected. I think they will give you some time to correct it also. Fine, after some time, maybe not now, but after some time, if there is any mistake you have done while submitting your form, fine, I think they will give some time to correct it. Okay, see clearly this one. So if you want, you can write the regular expression for this one. It is nothing but first one is M1. M1 is nothing but you can write 0 plus 1 0. 0 plus 1 0 what we have clean closure, and we have what 1 1 1 1 0 plus 1 0 clean closure. See 0 0 plus 1 0 1 0 clean closure plus 1 1, and what we have 0 plus 1 star. 0 plus 1 star. That is nothing but first one. Fine. What about M2? If you talk about M2, my dear friend. See, if you talk about M2, it is nothing but 0 plus 1 star, 0 plus 1 star, find 1 1 1 1 0 plus 1 star. Yeah, so I think yes, M1 M2, see here it is equivalent only. If you see correctly, they are equivalent. What you want to write with M1, definitely you are able to write with M2. Same it is. Fine. Any string, if you want to generate with this one, you are able to generate with this one also. So M1 and M2 are same. And see here it is MSQ question. I think two answers are correct. A is also correct. And see here, because both are same only, so L1 intersection L2 complement should be 5. Yes. So C is also correct because both is same, both machine are same. So definitely if we see here, L1 intersection L2 complement will be what? 5. Definitely fine. L1 intersection L2 complement is what? 5. Because see, whatever L2 complement is what? L1 complement only. So common will be 5 only. So C for Chennai is the right answer for this one. Okay. Now you can try this question. Fine. This is easy one. The answer is this one. Only see here in the exam, in the question they have given this one is Q and P. I have corrected it. You can try. Fine. Just you need to do the cross product of Z cross I and you will get this table. Fine. It is easy question. So match the following NFA with the regular expression. They corresponding. You can try this question, please. Everyone, please try this one. Okay, Abhishek. You can try this one and please let me know what is the correct answer. See, this kind of question, you can just see the option and with the help of option, you are able to try to solve this. See the option here. In all options, they have given S is 4. As option is 4, my dear friend. S is 4 means this will be matching to this one. Fine. So no need to try for this one. No need to try for this one. Fine. And if you see clearly, see which automata, which automata is what? Ending with 1. I think in P, Q and R. If you see clearly, it is nothing but R. And see clearly here ending with 1, my dear friend, it is nothing but third. So R is definitely 3. Sorry, R is definitely 3, my dear friend. R is definitely 3. See clearly here. With the help of options, you can try. Fine. R is definitely 3. So here R is definitely 3. So I think this one is gone. R is not 3. And this one is gone. So A, see here. So this one is gone. Fine. Now we have A and C, my dear friend. A and C. A and C, my dear friend. Are you getting my point? A and C. Now if you see clearly, the minimum string accepted by P is nothing but 0, 0. The minimum string accepted by P is nothing but 0, 0. 0, 0. Fine. Am I right? 0, 0. 0, 0. Even also the minimum string accepted by Q is also what? 0, 0. Q be 0, 0 accept kar raha hai. Q be 0, 0 accept kar raha. Fine. So even though for this one also if you see, because 0, 0, if this one also you can absolute P will not match to 3 and P will not match to 4. Because see 0, 0 will not accepted here. And see here, fourth one 0, 0 is also not here. See 0, 0 should be there. See minimum string 0, 0 here. No? Fine. So 0, 0 also here also not. So P cannot be 3 and P cannot be 4. Now my dear friend, if you see clearly, now if you take here, the minimum string is 0, 0. Now if you try for 0, 0, 1, 0, 0, 1. See the next string, see here 0, 0 and 1. It is accepted by where? It is accepted by what? P. The next minimum string, see 0, 0, 1 is accepted by what? Accepted by P. This is the next minimum string. Now see clearly, see 0, 0, 1. So 0, 0, 1. Fine. I think 0, 0, 1. Where it is? Where it is accepting 0, 0, 1, my dear friend? 0, 0, 1. See clearly? In the very first option, see 0, 0, 1. In this option only. Fine. So P should be 1. P should be 1. So P should be 1. P should be 1, my dear friend. P should be 1. So C is the right answer. P should be 1. So we have already, yeah. So A will not be the answer. So yes, C is the right answer. Fine. You need not to check for other one. Fine. Because this question you can try hit and try only. Fine. Hit and try and you are able to solve the question. Fine. 0, 0, 1. Because here, see here, second one will be not accept 0, 0, 1. Are you getting one? It is ending with 0. It is ending with 0 always. It is ending with 0. So you can hit and try and you are able to solve the question. So that's why the answer will be what? C. C for Chennai is the right answer. Even though you can do more analysis, but see here, sometime if you are able to see the option, my dear friend, you will definitely give the answer. See, S is 4. Now R is definitely, if you see R is definitely 3, my dear friend. R is definitely 3. So R is 3 here. Fine. Now we have what? Only check P and Q. So P, if you're checking, it is accepting 0, 0, 1. See here, so we have only one option. In first option, it is accepting. So you will go with first option, fine. No need to see every option, fine. If you try, you can analyze. It will take time also, fine. But like smartly, you can solve this question, okay? Now see this question, they are talking about regular set. They are talking about regular set, my dear friend. Regular set, okay? So see, this one is what? Regular, fine. Definitely you'll make DFA of this. You can write regular expression for this, fine. Yeah. And if see here, one comparison is there, n equal to 2m. So definitely it will not be irregular. It will not be regular. This is also one comparison is there. It will not be regular. And this one also, my dear friend, it is what? See, x, c, y, x comma y belongs to a comma b clean closure. It is nothing but c, and what we have? See, we have a plus b star, and what we have? We have what? A plus b star. It is also what? Regular language. So first and fourth is regular. So first and fourth, yeah, A is the right option for this one. See, A is the right option for this one. See, if you one compare, it will be a CFL. More than one compare, CSL, fine. One compare only, na. So it is what? CFL. It is what? CFL. Okay. This is what, my dear friend? Regular language. This is what? Regular language. If you make DFA or if you make regular, if you write regular expression, it will be a DFA. So this will be the right answer. Okay. Now, see this question. Okay. Which of the following language is generated by the given grammar? I think this question will be like this. Which of the following grammar is equivalent to the given grammar? Fine. Not because I think it will generate all. Fine. So the question must be like this. Maybe which of the following language is equivalent to the given grammar? See, I think it is a famous grammar also. See here, S goes to AS, BS oblique null. Fine. So it is, or you can write S goes to, it is the right linear grammar. You can write left SA oblique SB oblique null. Fine. It will always generate what? I think you know, A comma B star, or you can write A plus B clean closure. This one will be equivalent. Fine. I think it is MCQ question, 2016 question. Fine. So this one will be equivalent to this one. It will generate what? A plus B clean closure. A plus B clean closure. I think everyone knows. S goes to AS. See here. AS. What do you want to see here? It will generate what? All. See, all combination of A plus B clean closure. Fine. If you want, see clearly here. If you want, you can write null. So single A you can get. Fine. You can get everything. A plus B clean closure you will get. A plus B clean closure you will get. Fine. So it is equivalent to this one. Is that clear? If you want, you can see here AS. Fine. Now you can write here BS. Fine. You can write any number of A, any number of B, single A, single B, fine, double B, whatever if you want, you can try. Fine. Everything you got means A plus B clean closure. जो भी string इससे मिलेगी सारी चीजें मिलेंगी ना आपको इस grammar की help से. Fine. Or you can write this one also the same. Okay. Now see this one. This is also very tricky question. Which of the following regular expression represent the language? The set of binary string having two conjugative 0 and two conjugative 1. Two conjugative 0, they are telling, see here, two conjugative 0 and two conjugative 1. Fine. This one they are telling, fine. Two conjugative 0 and two conjugative 1 means, see here, what we have? Anything, see here. Let's suppose it is nothing but anything. What happened? Sorry. So yeah. So it can be 0 0 or anything, or it can be, see here 1 1 means here anything will be 0 plus 1 clean closure, or 0 0, then x, then what we have 1 1, then what we have, then what we have 0 plus 1 clean closure. Fine. So if you see clearly here, C option nahi hoga na, 0 0 and 1 1. They are talking about 0 0 or 1 1. Fine. So C will not be the option. Fine. C will not be option. And this is nothing but starting with 0 0 1 1 or starting with 1 1 or 0 0. So C and D will not be the option. Fine. You can see, you can skip, you can just remove the option like this only. Fine. You can just see this. See here. Here we have what? 0 0 and here we have what? 1 1. See, it is OR actually. Fine. So they are asking about 0 0 and 1 1 should be there. Fine. And here see, it's starting with 0 0 or 1 1 or starting with 1 1 or 0 0. No, we don't want actually. So this is nothing but see, before 0 0 anything will come x, after anything will come 1 1 x. Fine. So if you see what, my dear friend, if you see the option B, it is equivalent to this one. B option. If you see clearly, B option, B is the right answer for this one. Actually, A will also not work. Fine. See clearly, it is nothing but see 0 plus 1 clean closure. Fine. Just take x common, or what you can say 0 plus 1 common. What we have? We have 0, 0, 0, 0. And see, this one is nothing but 0 plus 1 clean closure. This is nothing but 1, 1, 1, 1. Plus what we have, my dear friend? Plus 1, 1, 1, 1, 0 plus 1 clean closure, 0, 0. Fine. And 0 plus 1 clean closure. Yeah, it will be the right answer for this one. So B for Bombay is the right option for this one. Fine. B for Bombay. You can try this. If you have doubt, you can ask me. Anyone? You can see here. See, it is telling 0, 0 and 1, 1. Na? So it can be, see, 0 plus 1 clean closure, 0, 0. Fine. 0 plus 1 clean closure, 1. 0 plus 1 clean closure, 1, 1. 0 plus 1. Or you can start with 1, 1 also. No? It can be start with 1, 1. Sorry, you can start, see, 0 plus 1 clean closure, 1, 1. Or 0 plus 1 clean closure, 0, 0. Or 0 plus 1 clean closure. Yeah, that is right. The full expression of this one is like this. Fine. Okay. For A, if you want, you can try 001, 001. So can I have 00? No, I think 001 and 011. If you try this one, see, if you try this one, 001, 011. Fine. This is string. If you try, my dear friend, it will not be accepted here in A. It will not be accepted. See, I am telling 00. See, 00. See, 1, 1. See, after 0 will come. See, it will not get accepted here. Fine, definitely. So A will not be the option. Fine. If you see B, B is the right option here. B is the right option here. Fine. See clearly here. 0 plus 1 clean closure, 0, 0, 0, 0. 0 plus 1 clean closure, 1, 1. 1, 1, my dear friend, 1, 1. 1, 1. Plus what we have? Either start with 0, 0, either start with 1, 1. Yeah. So B will be the right answer for this one. B will be the right option. Fine. B will be the right option for this one. Let me. Maybe this should be not be there. Fine. Yeah. I think it is fine. So anyhow, B will be the right answer. Okay. I'm moving now. Now, the number of states in the minimum size DFA that accept the language defined by the regular expression. Fine. Defined by the regular expression. So it is nothing but, see here, 0 plus 1 star, 0 plus 1, 0 plus 1 star. It is nothing but, see, 0 plus 1 into what? 0 plus 1 star. And this one is nothing but, see, 0 plus 1 positive closure. Positive closure. So how many states will be there? So this is nothing but Q0. And what we have, 0, 1, and one more state we need. And we have 0, 1. So how many state here we have required? 2 states only. So the answer will be 2. So if you know, see some formula, it is very easy to solve this question. Fine. So 0 plus 1 and 0 plus 1 star. See, you know A star. What is A star? A positive closure. Fine. So 0 plus 1 positive closure, and this is a DFA for this one. So only 2 states are required. So answer is what? 2. Answer is what? 2. Okay. Now, see clearly, consider the following two statements. If all states of NFA are accepting states, then the language accepted by the NFA is sigma star. No, it is in case of DFA, but not in case of NFA. Fine. They are telling if all states of NFA accepting means accepting states, or you can say final state, or you can say final state. Fine. Final states. So see, if all states of NFA are final states, then the language accepted by the NFA is sigma star. No. In case of DFA, it is possible. Even though if we make all final state also, it will not accept all. See, it will not accept sigma star. Fine, definitely. If in case of DFA, it will. In NFA, it will be false, my dear friend. If you make also all final state also, it will not accept sigma star, my dear friend. Yeah. Now there exists a regular language A such that for all language B, A intersection B is regular. Yes, that is true, my dear friend. Fine. I think this is a property also. If you see, let's see here, regular intersection anything. See, regular intersection anything. See clearly here. See, even though what they're asking, there exists a regular language such that for all language B, For all language B, A intersection B is regular. Yes, like if you see here, there exists a regular language. Let's suppose phi is a regular language. Intersection B is what? It is nothing but phi, and it is what? Regular language. Yes, that is true. See, there exists a regular language. They are asking. There exists a regular language such that all language B, A intersection B means phi intersection B will be what? Phi. Yes, it is a regular language. Fine, it is a regular language. So answer will be what? I think first one is false, second is true. First one is false and second one is true. So only one is true, only second is true. So B is the right option. Only B is true. Fine. Okay, I'm moving now. So the language by a push on automata which stack is limited to 10 items. The best describe is, see here, see, they have given the language accepted by a push on automata which stack is limited. If it is limited, it is nothing but like regular. Already we have seen. Something is limited, it is accepted by what? Finite automata, and it is regular. Fine. So regular is the right answer for this one. Now try for this one. Try for this one. See, clearly they have given some option. Fine. And they have clearly telling L1 is not regular. In option C, option B, only option looking B, you are able to give the answer because it is what? MCQ question. It is not MSQ. And see here, it is not regular. Yes, it is not regular, my dear friend. Comparison is there. So L1 is not regular, definitely. And B will be the right option. B will be the right option. I think you can guess here. Fine. In first one, they are telling L1 is not a CFL, but L2H. Fine. L2H. And second one, they are telling L1 intersection L2 is phi. And L1 is non-regular. L1 union L2 is not a CFL, but L2H. There is a 4-state PDA. See the option clearly here. See, this one is what, my dear friend? This one is definitely what? Non-regular language. This one is definitely what? Non-regular language. Fine. Even though, see, this is also CFL, second one. This is also CFL, my dear friend. So the option is what? B only. B for Bombay is the right option for this one. Fine. Okay, I'm moving now. We need to solve other question also. Now see this question. They have given S is the start symbol and A or B non-terminals and 0 and 1 are the terminals. The language generated by the grammar edge. The language generated by the grammar edge. The language generated by the grammar edge. See clearly what B is generating. B is generating is nothing but, see, 0, B, 001. Fine. It is nothing but, see here. If you see clearly, it is generating here 0 to the power n and B will replace with 1, 1 and 00. Where what? N should be what? Greater than equal to? N should be what? Greater than equal to 1. Fine. See, this is nothing but B. B is generating this one. So this, see, this cannot be the option. Here they are telling here I think in N should be, okay, N should be what? Greater than equal to 1 or 0. You can get 1 also, no? So it should be 0. N is greater than equal to 0, my dear friend. See clearly here, 0 B, because B se kya mil sakta? See here. From B you'll get 1 also. Fine. So there is no 0. There is no 0. From B you are getting what? See, from B you are getting 0, B, 0, 0. And from B you are getting 1. See, are you getting my point? So it is nothing but 0, 0, 1 to the power, 0, 1, 00 to the power n, 00 to the power, or you can write 0 to the power n, 1, 0 to the power 2n, such that n is greater than equal to 0. Fine. It will be better. You can write like this. Fine. So yeah, you can delete this option. Fine. So see here. So here they have written n greater than 1. So see here they have written n greater than equal to 1. So this cannot be the answer. Here they have written n greater than equal to 0. Yeah. See, n greater than equal to 0. That is right. That is right, my dear friend. N is greater than equal to 0. Fine. That is right. That is absolutely right. Fine. No problem. Now see clearly this one. This is nothing but, if you see this one, A0, A0 and 1, my dear friend, it is nothing but what it is generating. See clearly, A, 0A. Fine, 0A. Now you can write 0A, 0A. Fine. So it is nothing but, see, it is nothing but what they are generating here. See, they are generating, see, 0, 0 star. Fine. 0 star, 0 star, and they are generating 1 and 0 star. Fine. If you see clearly, this is generating, see, 0A, A0, 1. If you draw the pass tree, it will generate 0 star, 1, 0 star. Now, if you see clearly here also, so it will generate what? What is A? So it is nothing but, see, 0 star, 1 0 star, and once again A, so it is nothing but 0 star 1 0 star 1 0 star, and B. What is B, my dear friend? B is nothing but what is B? B is nothing but this one. B is nothing but already we have written this one. So if you see clearly, it is nothing but, if you write this one, it's nothing but 0 star 1 0 star 0 star 0 star 0 star, fine, and we have 1 0 star. So see clearly in third option, see 0 to the power I 1 0 to the power j 1 0 to the power k, where I j k is greater than 0, fine, where I j k is greater than 0 union this one. So this will be the right option. See, this one is the right option, fine. Is that clear? Fine. And see, this is containing the set of all string over containing at least 2 0. It is absolutely wrong. See clearly here. Fine. So D is wrong. So C for Chennai is the right option for this one. Okay. Now you can try, this is easy question. Question number 18 you can try. Simply you need to derive. Fine. This one is also easy based on the previous one. Fine. So every left recursive grammar can be converted into a right recursive grammar and vice versa. Yes, this is true, definitely. Fine, we have seen. All null production can be removed from any context-free grammar by suitable transformation. No, like if the grammar itself contains null, let's suppose. Fine, L goes to A star. No, means if it contains null only, you cannot remove. So this is false. This is false. The language generated by context-free grammar, all of whose production are form X goes to W or X goes to WY, where W is a string of terminals and Y is a non-terminal, is always regular. Yes, it is a right linear grammar. Yes, it is what regular. So third one is true. The derivation tree of a string generated by a context-free grammar by Chomsky normal form are always binary tree. This is also true. So the answer will be what? We have, I think they are asking about true. So 1, 3 and 4. 1, 3, 4. So C for Chennai is the right option. C for Chennai is the right option for this one. Okay. Now see this question. You can try this question. It is also easy question. Match of the following only. Fine, you know palindrome and all. Fine, you can try this one. I'm moving to next question. Okay, answer for this one is nothing but 3, 1, 2, 4. Fine, C for Chennai is the right answer. Okay, now see, which of the following are decidable? They are asking about decidable. So whether the intersection of two regular language is infinite. Yes, it is decidable only. Decidable means algorithm exists or not. Fine. Whether the intersection of two regular language, fine, R1, R2 is infinitive or not. See, yes. For this one we have the algorithm, so it is what? Decidable. It is decidable. Whether given context free is regular. Whether the given context free is regular, my dear friend, that is the regularity of context free grammar. That is undecidable. So it is what? Undecidable. No algorithm is there. This is what? Undecidable. No algorithm. Undecidable. Fine. Whether two push-down automata accept the same language, equivalence problem of CFL, it is also undecidable. This is also undecidable. Fine. Now, whether a given grammar is context-free, yes, it is decidable only. We have algorithm. We have like methods to check whether the grammar is context-free or not. So decidable, you can say 1 and 4. B for Bombay is the right option. Fine. For this one, you need to prepare the chart. Fine. With the help of that, you are able to give the answer. Fine. So this is nothing but infiniteness of regular problem. Fine. Yes. This is nothing but regularity of context-free undecidable. This is what equivalence of context-free undecidable. And this is what decidable only. Yes. Fine. Okay. Now, which of the following statement is false? False they are asking about. Every NFA can be converted to an equivalent DFA. Yes, this is true. Every non-deterministic Turing machine can be converted into the equivalent deterministic Turing machine. Yes. Every regular language is also context-free. Yes. Every subset of a recursive enumerable set is recursive. No. Fine. This is what false. So answer is what? D. D for Delhi is the right answer for this one. Fine. D for Delhi. Okay. Now see this question. This question is easy also, but little bit tricky if you try with the help of, see the option clearly here, and definitely you are able to give the answer. See the grammar here. See, S goes to, see the grammar. S goes to AS oblique B, and B goes to what we have? B, my dear friend. B goes to what? What we have? BB. Fine. So see what it will generate. So just you can use a bottom approach here. See what it is generating. It is generating what? It is generating what, my dear friend? See, if you see clearly, B goes to single B, or B goes to what? BB, or B goes to B. So it is generating what? See, B closure. So this is nothing but B closure. So you can replace with B closure here. Now what it is generating? See here, S goes to AS oblique B closure. It is nothing but, see clearly, it will generate what? It will generate A clean closure, B closure. Fine. A clean closure and B positive closure. Are you getting my point? See clearly here, S goes to AS, S goes to AS. Fine. And what we have, S goes to AS, S goes to AS. See clearly, S goes to AS. So this is nothing but A plus, and see here we have no A. So here we have no A, 0 A also, no? That's why A star I have written here. So A star B closure, A star B closure, B positive closure. Now see clearly in the option, if you see here, they have written here, they have written A to the power M, B to the power N, M greater than 0 or N greater than 0. So here OR, so OR will definitely not be the answer. See, OR will definitely not be the answer. So A and D will be gone. A and D will be the one. Fine. Now if you see clearly B and C, my dear friend, B and C here, if you observe clearly here, they have written and here, no problem. But see, now if you write in terms of this, it is nothing but, see, A star means M should be greater than or equal to 0. So see here, where, see, M is greater than 0 and N is what? Greater than 0. N is what? Greater than 0. Here M is greater than 0 they have written. So this is wrong. B is wrong. So C is correct. C is correct. Even though, see, there is no need of this grammar in this question. Fine. So if you're starting from G1, even though if you see only, you know, like which language it is accepting, this one, my dear friend, you are able to give the answer. You are able to give the answer. Try for this one also. Like you can use like bottom up approach only. Like see here, like this only. S goes to what we have? We have A, B, B. And A goes to what we have? We have A, B, oblique null. And B goes to what we have? B goes to what we have? B, oblique null. So it is generating what? This one is generating B clean closure. Fine, due to null, B clean closure. So you can just replace with this one, B clean closure. So what they are generating? This is generating this one is generating is nothing but A star, B star, A star, B star. So you can put A here. So what is generating? See, A you can replace with A star, B star, B star, and what we have? B you can replace with what? B you can replace with what? B star. Are you getting my point? B star. Fine. And try to solve this. You will get the answer. Fine. So you will get, anyhow you will get C. Fine. You will get C also. Fine. Is that clear? You can try this. It is very simple method. Fine. Okay. So I think, yeah, C is the right answer. We have more question left. So I'm moving quickly. Now, see this question, try this question. Please let me know what is the correct answer for this one. Everyone, please let me know the correct answer for this one. I'm waiting for the answers. Please reply. See clearly here, they have given here, consider the transition diagram of PDA given below with the input alphabet sigma A comma B and stack alphabet this one X comma Z, where Z is the initial stack symbol. Means in the stack they have given Z is there. Z is there. Fine. Okay. Let L denote the language accepted by the PDA. They have given the PDA. See, see what they are telling here. What they are telling here. See clearly. This is nothing but see. Whenever this is, if you want, you can just take this is nothing but Q0, this is nothing but Q1, this is nothing but Q2. So here we have 3 states here. Fine, 3 states. So whenever whenever input is A, what? Push X into the stack. Fine. Whenever input is A, once again push X into the stack. It is nothing but push A and push X into the stack. This is nothing but, so whenever input is B, pop X from the stack, and this is nothing but here completion. Fine. So they are talking about which of the following is true. See clearly here. So see here Q0. I am on Q0. If I will get A, what I will do? I will push what? I will push X on the stack, and it will what? I will reach on Q0 only. Are you getting my point? Fine. So see, if I will get A only, I will reach on Q0. If I will get A also, see, if I will get A also, A also. Once again, what happened if I will get A also, my dear friend? See, on Q0, if I will get A, so where I will on Q0 only, fine. Q0, I will push X. One more A, I will push one more X here, fine. And I am Q0 only. It is nothing but see, it is nothing but A to the power N. And N is what? Greater than or equal to 0. Why? Because initial state is a final state. So it is also accepting what? Null. So it is nothing but A star. It is nothing but A to the A star. It is nothing but A to the power N, which is where N is greater than 0. Why N is greater than 0? Because this is initial is final state also. Fine. So this is nothing but A to the power N. N is greater than 0. So see clearly here. So yeah, here also they have written, here also they have written. So A to the power N. But here they have written is not accepted by the any deterministic PDA. No, it is wrong only. See, this is A to the power N and greater than 0. And what is Q2, my dear friend? What is Q2? It is nothing but, see here, A to the power N and B to the power N. Yes. So A to the power N and B to the power N. Fine. Greater than or equal to 0. So it is deterministic context free. Yes. A to the power N and B to the power N is what? Deterministic context free. So D for Delhi is the right answer for this one. Fine. D for Delhi is the right answer for this one. This is nothing but what? See, input. See here. See, this is for what you need to pop. This is for because no transition is there. So this is for acceptance purpose only. Fine. Yeah. So this is nothing but A to the power N, and this will be equivalent to what? A to the power N and B to the power N. So that's why the answer will be what? D. D for Delhi is the right answer for this one. Fine. D for Delhi. Okay. Now, if you see clearly this one, animal is a language defined by the grammar S1A, S1B null, and S2 is A, B, S2 null. So, which of the following is true? So, see clearly it is nothing but A, S1B. See here, it is nothing but A to the power N, B to the power N, where N is what? Greater than or equal to 0. Fine. Is that clear? And this is nothing but, everyone know, this is nothing but A plus B whole star. Fine. A plus B whole star, my dear friend. So, it is nothing but regular only. So I think first one is what? CFL, and the second one is what? Regular. So both P and Q true? No. Regular they are asking. P is true? No. P is false? Yes. And Q is true. So C for Chennai is the right option for this one. C for Chennai is the right option for this one. Fine. Please reply. Okay. You can write in the form of this one, AB to the power N. No? You can write, if you want, see S, A, B, S2, fine. A, B, S2, S2, you can write AB to the power N such that N is greater than or equal to 0, fine. This is nothing but A plus B closure only. Okay, so yes, this is right. Now, okay. Okay, so I think we don't have time. So yeah, you can just try this one. See this question. A to the power N, B to the power M, C to the power N plus M, M is M, comma N greater than or equal to 1. This is nothing but what? DCFL, fine. Deterministic context free language. Deterministic context free language. Just see clearly. Push A, push B, and what? Pop with the help of C. Yes, this is DCFL. No? This is DCFL. Fine. And this is nothing but CSL. Fine. This is nothing but CSL, my dear friend. Context sensitive language. Now, more than one comparison here. Fine. So DCFL and CSL. So they are asking about which of the following is true. So L2 is context free, no. L1 is context free, while L2 is not context free. Yes, B is the right answer. L1 is DCFL. Why? See, push A means whatever A is there, just push it. Fine. Push B and pop with the help of this one. Fine. It will be equal to power of A and B. Yeah, B will be the right. L1 is context free, while L2 is not context free. Okay. See, which of the following is true? The complement of a recursive language is recursive. Yes, this is true. It is closed or non complementation. The complement of recursive enumerable language is recursive enumerable. No, this is false. The complement of a recursive language is either recursive or recursive enumerable. No. The complement of context free language is context free. No, this is also false. So A is the right option for this one. Fine. Okay. The C language is what? It is a what? Context sensitive language. CSL, my dear friend. Fine. It is a CSL because we need to once the variable which we want to use, fine, and once what? Formal parameter and actual parameter. So yeah, so that's why it is what? Context. All modern programming language, you can say it is what? Context sensitive language. It is what? Context sensitive language. CSL. So which of the following is a language? C. This is, I think everyone know, it is neither regular nor context free, but accepted by Turing machine. Yes, fine. we have discussed. And if L and L bar are recursive enumerable, then L should be what? L should be recursive. L recursive hona chahiye. Okay. And this question, see here, X be a recursive language and Y be a recursive enumerable language, but not recursive language. They are telling W and Z be two languages such that Y bar reduced to W. Fine. Y bar reduced to W and Z reduced to X bar. Z reduced to X bar. Fine. Which one of the following statement is true? They have given some options. See here, X bar is what? Recursive language. If X is recursive, X complement is also recursive. So see here, if this is recursive, this should be what? Reducible to Z. This should be what? Reducible. Means Z should be what? Recursive. So Z is recursive. Z is recursive. Where is the option? Z is recursive. See here in A and C, Z is recursive. And they are telling W can be recursive enumerable. See here, W they are telling it is recursive. It is what? Recursive enumerable but not recursive. So complement will be what? Not recursive enumerable. That's why what? Y bar also not recursive enumerable. W is also not recursive enumerable. Are you getting my point? So see clearly, W is not recursive enumerable and Z is recursive. Are you getting my point? Because Y is recursive enumerable. If Y is recursive enumerable, my dear friend, Y is recursive enumerable. Fine. The complement need not be recursive enumerable. That's why the answer will be what? C. Answer will be what? C. Fine. Okay. You can try this question also. Fine. L3 union L4 is recursive enumerable. What is L3? L3 is what? Recursive. L3 is what? Recursive. So recursive complement is what? Recursive. Union L4. Yes. It is recursive enumerable. Yes. No problem. So first one is true. Fine. It is recursive enumerable. What about this one? L2 complement union L3. What is L2? L2 is what? Context free. So context free is not closed under complementation. Fine. Union L3. What? L3 is what? L3 is what? Recursive. So it is nothing but see L2 you can just go. L2 is not closed with CFL is not closed with the complementation. Fine. So just CFL complementation union what? Recursive they have written. So it is nothing but just you go per CSL union recursive. It is nothing but recursive. Fine. Recursive. So second one is also true. And they are asking about true only. Fine. They are asking about true. Fine. Now see clearly L1 star. L1 is regular. So regular star is regular only. Regular intersection anything is what? Context free. Yes, no problem. This is also true. See L1 clean closure. It is nothing but regular. Regular clean closure is regular only. A regular intersection CFL. It's CFL. It is also true. What about this one? L1 union L2 complement. What is L1? Regular. So regular union CFL complement. So CFL complement is not closed under complementation. So it is nothing but regular union CSL. So it should be CSL, my dear friend. It should be CSL. So answer will be what? 1, 2 and 3. D is the right option for this one. D is the right option for this one. Okay. Okay. Fine. We have only 3 minutes. So yeah. This one, see, this is recursive. This one is recursive. This one is also recursive. This one is not recursive. You know, like membership. Turing machine does not. Turing machine membership is undecidable problem. So yeah, L1 and L2 is recursive and L3 is not recursive. Fine. This one also you can try. Is in given NFA N1 N2. See, this is what? Disjointness is equal to 5. Yes, it is what? Decidable. This is decidable. Disjointness in what? In regular language. Decidable. Given a CFG and a string X belongs to sigma star does belong X belongs to LG. This is also decidable in regular language. Fine. Equivalence, it is undecidable. Turing machine LM equal to 5, undecidable. So 3 and 4 is undecidable. So 3 and 4. So C, I think they are undecidable asking. So C is the right answer for this one. Okay. Fine. So I think we have done. So this is the class. Fine. After 1 hour, I will take GATE 2021 PYQ. Fine. Please join the class on my BYJU app. You can join my class on the BYJU app, my dear friend. And yes, this is very important. You can register here. Fine. Avinav Negi sir is taking workshop on 20th of September. How to get 80 marks GATE with 75% syllabus. Fine. Sir will tell you. Fine. How you can get 80 marks, my dear friend. And definitely it is very helpful for everyone. Fine. And on 17th September, there is a scholarship test. Try to participate if you want to enroll and you want to get maximum discount. And already Vision crash course GATE has been started. Fine. Limited seats are available. You can enroll as soon as possible. So yeah, this is my Telegram link. Thank you so much. Please like and subscribe the channel if you don't. Till now, if you Fine, and please like and share. Thank you so much. We'll meet you tomorrow. Thank you so much.